Hello, welcome to second sessions of Global Supply Chain Design. In this session, we will learn about processes, systems, and models used in supply chain and operations management. And the learning objective for the chapter is that first, to find the interrelations between business processes, quality models, and information systems. So first we need to understand what is business processes, what is process, and what is business process, and what qualitative models can be used to formulate that those business processes, and what information systems can operationalize those quantitative models of business processes. The second objective is to find the role of business process management in operations and supply chains. And the third objective is to find the effect of management of information systems in SCM, because SCM actually driven by the advance of information technologies. And what kind of technologies used in management information systems? We will little bit studied about ERP system, that's Enterprise Resource Planning, Advanced Planning System or APS, Warehouse Management System or WMS, and RFID or Radio Frequency Identification. And in order to compose the quantitative models of supply chain and operation management, then the models will represent the planning of the supply chain networks or the operations networks. And then that planning will be formulated into problems. And the goals of the problems is to make a decision about supply chain planning. And we also studied about the role of models and modeling in decision making. How do we quantify supply chain and operations management decision by using models? And in order to solve the model, we need some kind of like quantitative methods. So what quantitative methods used in supply chain and operations management decision making? That's all what we will learn in this chapter. Okay, now let's go. Okay, now we are entering into case study about air supply. Air supply is supply chain for aircraft manufacturer. So in each time an aircraft is made, it is the result of assembling a multitude of parts representing a very large volume of orders. And what's true for the aircraft assembly line is true for the whole aerospace industry, but not only aircraft, but also helicopters and satellites are built. And parts for manufacturing are coming from multiple suppliers and from all over them. Most of those suppliers are quite complex and need to fulfill the highest quality standards. So each time delay can cause very high costs. So it is essential that all suppliers involved in the manufacture of an aircraft have a real-time visibility of the progress of demand and inventory to adapt to fluctuations and changes of customer requirements. So it is essential for customers and suppliers to have a common tool that will enable them to better collaborate and to gain visibility of a demand as well as inventory. So from our picture, actually, there are two different business processes here, in-house and also external partners. In-house, they are integrated electronic processes, while in with external partners, there is no integration, unstructured. Also, the process is intransparent because they do not share the information to their partners in this air supply chain. So, such a tool that can be seen in the example of air supply chain solution that was developed in collaboration with Airbus and other major manufacturers and suppliers in the European aerospace industry. So, for instance, if air supply is mainly characterized by the networking of the whole aerospace and defense supply line, its main innovation lies in the fact that it will provide all users with one single tool. In other terms, the same view on demand and inventory data. And therefore, because of no integration and the new solution proposed by Airbus and EADS would be address these obstacles. And the solution combines major new technologies such as cloud computing, software as a service or SaaS, and e-procurement. It was developed in cooperation with SupplyOn, which had many years of experience with web-based supply chain management solutions in the automotive industry. And therefore, for this case study, at least there are three technologies or information technologies applied. First, it is some kind of forecast collaboration, which need each players in the supply chain share their domain data, and e-procurement, and finally vendor managed inventory. And what are those? We will explain in the later of this course. Now we are going into process management. A process is a content and logic of sequence or function or steps that are needed to create an object in a specified state. Meaning that if you uh, want to have a process of uh, learning supply chain management in this course, then the process should be first you have to register, and then you have to attend both online and offline learning, and you have to also submit your assignments and work on your homework, and also attend your exam before you get the grade. All of those are process of getting your expertise in supply chain management by completing this course. But you cannot randomly change the sequence. For instance, you need to have exam in advance. Not possible, because it is not according to the approved process of learning supply chain management course. All right. And the second, a business process. Business process and networks of activities for accomplishing a business function. So processes have input and output parameters and may be tied to one functional area or be cross-functional. In our example here, we have three functions: sales, accounting, and manufacturing and production. And each function consists of at least two processes. First, we have uh, two functions here. For instance, generate order and submit orders in sales function. In accounting function, we have a logic of sequence from check credits, approve credits, and generate invoice. So in manufacturing, we have two functions here: assemble the products and ship the product. So each function in one particular business process connected one of another in a specific sequence. And this connection is not only within a single business process, but can be cross-functional. For instance, between sales and accounting, there's a connection between submit order and check credit. So the conclusion of these slides is mentioned by Edward Demings, if you can't describe what you are doing as a process, you do not know what you are doing. Now we enter into business process management. So the basic concept for managing processes in an organization is called business process management. So business process management contains a variety of tools, methodology to analyze, design, and optimize processes. So here by Hammer and Champy in 1993 composed 5 steps of uh, producing or building business process management. First, we have to identify processes for change and then analyze the existing process, design new process, implement a new process, and continuous measurement. Okay, for instance, I have an okay process can be optimized subject to finding their best state with regard to the following: cost, time, quality, capacity, flexibility, sustainability, and risk. Cost. One example of cost is that production cost. It can be any other cost, like distribution cost, like storage cost, etc. Time represents a service level. The longer time needed to process or to produce, then the service level becomes lower. Quality, how much waste to be produced from particular process. Capacity, how much the utilization of a particular machine. Flexibility, meaning how many variety of product can be produced from a single particular machine. Sustainability, how many or how much carbon emission emit by a particular process in a production or in distribution or in storage. And risks related to resilience of the supply chain networks. The process analysis results may be characterized by effectiveness, that is the achievement of process goals, and efficiency, that is performing the process with minimum cost. Processes that are both effective and efficient are named optimal. So optimal processes are characterized by effectiveness, efficiency, controllability, stability, flexibility, analyzability, observability, reliability, documentability, and permanent improvement capability. All right, now let's go to the next page. This one example of service level. Service level here is defined by the total customers orders minus dropped customer orders, that is back orders, divided by the total customer orders. And capacity utilization is defined by actually used capacity divided by maximum capacity. And in the bottom, we have two definitions of time. First is lead time. Lead time is defined by the time needed to process customer order, starting from customer order arrival until customer order delivered. While flow time is the production time, when the production is started and when the production is finished. Now we are going into business process modeling. Supply chain management process orientation has been stressed before and since Porter's introduction of the value chain. The value chain itself is a paradigm has been developed in economics that process-oriented management leads to superior results compared to the traditional focus on functions. So when analyzing supply chains, the modeling of processes is an important first cornerstone. In this context, several questions arise. First, which processes are important for the supply chain? And the second, how can these processes be modeled? and therefore process model have to describe the supply chain and operations management activities from information processing perspective. This process modeling can be referred to a descriptive modeling and serves as an interface to information system development. And therefore, process models can be used to describe the workflow decision-making process. There are several types of process models. First, we use SCORE, that is Supply Chain Operation Reference. Second, we use ARIS, Architecture of Information Systems. Third, we can use also UML, that is Unified Modeling Language. And finally, we have also IDF, Integrated Definition for Function Modeling. Among these four, SCORE is the mostly used by supply chain practitioners and academicians. So, what is SCORE? The SCORE model, or Supply Chain Operations Reference, is a tool for representing, analyzing, and configuring supply chains. The SCORE model have been developed by the Supply Chain Council, or SCC, founded in 1996 as a non-profit organization by EMI Research, the consulting firm, and also by 69 companies, that is from as a member of Supply Chain Council. So in 2007, Supply Chain Council had approximately 1,000 members, mainly practitioners, enabling technology providers and consultants. The SCORE model is a reference. It does not provide any optimization method, but aims at providing a standardized technology for the description of supply chains. This standardization allows benchmarking of processes and the extraction of the best practices for certain processes. Supply Chain Council recommends to model a supply chain from the suppliers of suppliers and to the customers of customers. Processes such as customer interaction, like order entry through paid invoice, like physical material transaction, for instance, equipment, supplies, products, software, and so on. Also market interaction, for instance, like demand fulfillment, and returns management are supported. Sales and marketing, as well as product development and research, are not addressed within the SCORE model. So the standard processes are divided into four hierarchical levels: process types, process categories, process elements, and implementation. The SCORE model only covers the upper three levels, that is, process types, process categories, and process elements. And let's now go into this figure. In this figure, we have at least three players in the supply chain. Let's say supplier or producer and also distributor. In each of these players, they have plan, source, make, and deliver. For level 1 of SCORE model, we can define plan that covers processes to balance resource capacity with demand requirement and the communication of plans across the supply chain. Also, in its scope are measurement of the supply chain performance and management of inventories, assets, and transportation, among others. What about source? Source covers the identification and selection of suppliers, measurement of supplier performance, as well as scheduling of their deliveries, receiving of products and processes to authorize payment. It also includes the management of the supplier network and also contracts as well as inventory of delivery products. So what about make? In this scope, make our processes that transform materials, intermediates, and products into their next stage, meeting plant and current demand. Make covers processes to settle production activities, produce and test, packaging, as well as release of products for delivery. Furthermore, make covers the management of in-process products or work in process equipment and facilities. And what about deliver? Deliver covers processes like order reception, reservation of inventories, generating quotations, consolidation of orders, load building, and generations of shipping document and invoicing. Deliver includes all steps necessary for order management, warehouse management, and reception of products as at a customer's location together with installation. It manages finished product inventories, service levels, and import or export requirements. And finally, we have return. In the scope, return are processes for returning defective or excess supply chain products. And the return process extends the scope of SCORE model into the area of post-delivery customer service. It covers the authorization of returns, settling of return, receiving and disposition of returned products, as well as replacement or credits for returns products. In addition, return manage returned inventories as well as the compliance to return policy. And therefore, we can conclude that the main value of SCORE is that the standardized business process models. And those models are interlinked at three levels, as I said before. In addition, a coherent systems of performance indicators is correlated with process model, and therefore data origins used to calculate performance are explicitly provided. Okay, now we go into the role of information technology or IT. So information, as we have learned in the previous slides, is a one pillar of supply chain and operations management, and therefore where information is missing, material is also missing. So can you imagine, for instance, as if you were a manager in such a warehouse, for instance like raw material warehouse, if the incoming material is not recorded properly, and then if somebody steal that material, you will never know, and you assume that there is no anything wrong with the process inside the warehouse, and therefore information is not less important than material or any other resources itself. So a universal property of the management processes, irrespective of the problem domain, is that it has notably informational nature. So collecting information, processing information, analyzing information, and use the data or information or knowledge is paramountly important in supply chain and operation management to be competitive. And what about the MIS or Management Information System? MIS is used to collect, to process, to store, and to distribute information in order to support decision-making, coordination, and control. And there are two kinds of data or two kinds of information here. First, it is a data that is a raw data or raw facts and information that has been processed into a meaningful form. So for companies, MIS is instrument for creating value, and therefore investments in a right IT can result in superior returns regarding productivity increases, revenue increases, and long-term strategic positioning. The role of MIS in supply chain and operations management is that to automate steps that were done manually previously. Also, MIS enable entirely new processes by changing flow of information to replace sequential steps with parallels to reduce time and to support new business models. There are several IT that can be used for SCM. For instance, planning at enterprise level. We recognize ERP, that is Enterprise Resource Planning, and then MES, Manufacturing Execution Systems, and WMS, Warehouse Management System. In planning and control for supply chain coordination, if in the planning at the enterprise level, mostly used in a specific location or specific entities in the supply chain, but in planning and control for supply chain coordination, it is a system that can glue or connect all members or actors in the supply chain networks. We know APS, that is Advanced Planning Systems, TMS, Transportation Management Systems, and SCM, Supply Chain Event Management. And also, we have also real-time control, mostly used in short-term planning in the supply chain. We know blockchain, RFID, some technology to track the delivery and position of orders at any time. And so TNT, that is trace and tracking, also ASN, automated shipping notification. I think some of this you already familiar when you make online order, for instance through eBay or Amazon, and then you will have ASN, like automated shipping notification, where actually your order now is located or the current position of your order. We have also business intelligence and industry 4.0. We have big data analytics. We have also industry 4.0, machine learning and cloud computing. Also, we have supply chain communication and data interchange like EDI, electronic data interchange, e-commerce, XML, also mobile technologies and Android, for instance, that we already have in our mobile phone. And also electronic payment system with security services like PayPal, for instance. Okay, in front of us is a connections or networks of IT systems for SCOM. All of these blocks are represented in the previous slides. What is SRM? That is Supplier Relationship Management. CRM, that is Customer Relationship Management. SCM, Supply Chain Execution Management, and e-collaboration. And all of these IT systems are capable of enhancing or optimizing the operations in the supply chains and operations. And therefore, there is one key important thing before investing in IT infrastructure. That is amount to spend on IT. And IT, even though can be bought, but also can be rented or used via cloud computing. IT can also be available via outsourcing. The most important thing here is that IT provide a new level of coordination capabilities in supply chain and enable a breakthrough in supply chain responsiveness and flexibility. Modern IT can potentially enable almost any integration and coordination concept. So more important problems for efficient coordination lie in the organization sphere, collaboration culture and trust. And therefore, the issue of investment in IT infrastructure should be highlighted. We have at least three here, the issues: amount to spend, IT can be bought but also can be rented, and even can be borrowed via outsourcing. Therefore, whatever option is selected, the total cost of ownership or TCO model for cost analysis should be used. It analyzes direct and indirect costs. Note that hardware and software costs account for about 20% of TCO. So other costs include installation, training, support, maintenance, infrastructure, downtime, space, and energy need to be considered. TCO can be reduced by the use of cloud services, greater centralization, and standardization. And second, IT project management is a critical issue. As in any project management, activities in an IT project include planning work, assigning tasks, controlling project execution, reporting progress, and analyzing the results. Five major variables for planning an IT project are as follows. That is scope, time, cost, quality, and risk. Now we are going into ERP system, that is enterprise resource planning. So what is actually enterprise resource planning? We have already known in the previous slide that enterprise resource planning is used internally in one particular entity of the supply chain. So an enterprise resource planning comprises integrated software modules and a common central database. So ERP modules include but are not limited to production management, inventory management, sales, human resources, marketing, and supply chain management. Modules can be seen as a number of USB sticks which can be purchased all together or in isolation. So ERP working principles is based on collecting data from different departments of a firm for use in nearly all of firm's internal business activities. And therefore, as I said before, ERP system is limited to the use internally, but not for coordinating or collaborating with other partners or other players in the supply chain networks. It includes finance, accounting, marketing, warehouse, customer service, manufacturing, and sales. So, in the advantage of using ERP is that it provides integration of the supply chain, production, finance, and marketing. It also creates a commonality of a database, can incorporate improved best processes, increases communication and collaboration between business units and sites, has an off-the-shelf software database, and also may provide a strategic advantage and increase company asset. And however, there are also some limitation in using ERP system. First, ERP system can be very expensive to purchase and even more so to customize. Implementation may require major changes in a company and its processes. Can also be so complex that many companies cannot adjust to it and involves ongoing, possibly never completed process for implementation. So expertise is limited with ongoing staffing problems. So actually, in implementing ERP systems, the TCO mostly uh, devoted for non non cost of goods sold. That is, the software itself is not that expensive, but other costs, for example, like training, also support system, also for maintenance, that is more expensive, and that cost actually should be invested in annual basis. Okay, in front of us is a diagram of ERP system, there are actually 4 blocks in ERP system that each blocks connects to the centralized database. Here we have finance and accounting blocks, sales and marketing, manufacturing and production, and human resources. So what's a function in finance and accounting blocks or modules? They are cash on hand, account receivable, customer credit and revenue. And sales and marketing includes order, sales forecasts, returns, requests, and price changes. And for manufacturing and production include materials, production schedules, shipment dates, production capacity, and purchases. For human resource include hours worked, labor costs, and job skills. So now the question is that whether we could purchase just a single what I say USB stick, in this case single blocks or single module like human resource for instance. Yes, we can, depending on our needs, our organization requirement. It is not necessarily to purchase all modules in ERP system, but we can purchase whatever modules that we really need to have in order to improve the performance of our organization in supply chain and operations management. There are some strength and weakness. As I said before, the strength is that it is integrated, operates in real time, and data is entered into system only once, meaning that if somebody trying to revise or to delete or to add something, once the data has been entered into the system, that he or she cannot do it, because the data is secure in a system, and therefore the data can be distributed securely to other function in the organization, and therefore there is no anymore some kind of like confusion in receiving data, in using data, and then for mistakes in in uh, inputting the data. However, there are some weaknesses. For instance, expensive. Yeah, implementation is time consuming and ongoing because of training, never ending training, because the vendor of the ERP system will always update the system and give additional functionalities that the organization must adapt, and also limited expertise. Hey, despite the advantage of using ERP systems, however, ERP system has some limitations. At the beginning of the 21st century, SCM topics become more and more important. Some important modules like supply chain design, distribution planning were missing for ERP system because, as we know from our previous slides, that ERP system is mostly implemented in a single entity of operations. For instance, in suppliers IT system, or in production uh, IT system, or even in one warehouse distributor warehouse IT systems. And therefore it misses some important modules like supply chain design, distribution planning, and any other, for example, like scheduling. And therefore, starting from the beginning of 21st century, another system, IT system, that is called APS, that is Advanced Planning System, has been introduced to fill the gap. And different to ERP system, ERP system had some other restrictions like planning against unlimited capacity. So if we go into a specific model like productions in an ERP system, the modules assume that uh, a particular facility has no capacity limit, and therefore it can be assigned for producing as many orders as possible. An ABS, on the other hand, uh, extract data for ERP system and use them for optimization And this is the key difference, that ABS have mathematical optimization in scheduling with regard to some limitation in production or in other functions. Okay, now I would like you to further reading from Stadler and Kilger, Supply Chain Management and Advanced Planning. In that book, you will see in more detail about advanced planning system and how do we use advanced planning systems in our organization or even in the supply chain operations. And in general, APS or Advanced Planning System describes any computer program that use advanced mathematical algorithm or logic to perform optimization or simulation on finite capacity scheduling, sourcing, and etc. And techniques simultaneously consider a range of constraints and business rules. And this is the uh, the benefit of using APS, and therefore our plan will be more feasible with regard to our process limitation. Often generate and evaluate multiple scenarios from the simulation, and therefore management will select the official plan that is more feasible, adjustable, and achievable by that particular organization. In general, advanced planning system consists several modules divided into different level of planning: long-term planning, mid-term planning, and short-term planning. And all of this planning distribute across function, starting from procurement, production, distribution, and sales. In long-term planning, we have modules called strategic network planning. In strategic network planning, it includes like how many warehouse we need to operate, and how many distribution centers or how many factories or manufacturing centers we need to invest. And therefore, it is long term, starting from 1 year to a longer term. In midterm, it is less than 1 year. We call it master planning. In master planning, the plan, how what kind of inventory policy we have to adapt, and how to distribute our products, and it includes also transportation planning. And all of this midterm planning receive the data from demand planning. Demand planning actually about forecasting how much or how many orders would potentially occur in the near future, and the data will be provided by marketing or sales department. From master planning, the information will be deployed into purchasing and material requirement planning, or MRP, in short-term basis. And also in short-term basis, we have production planning, distribution planning, scheduling, transport planning, and demand fulfillment and ATP. What is demand fulfillment and ATP? It is available to promise. ATP is available to promise, meaning that how much we have cushion in our production capacity that can absorb the uncertainty about our demand. And therefore, as at a glance, this advanced planning system is more advanced than ERP system that we have already discussed in the previous slides. Okay, however, ABS and ERP are well connected. So how it works? In the figure in our slides, ERP system provide data necessary for operating ABS. For instance, module operation planning will give input into decision on manufacturing start. And also module technology, human resource, inventory, plan, and controlling are distributed into ABS, and therefore the plan will create some kind of like a system or planning system that really reliable and feasible with regard to the limitation of the supply chain operation. And what is the important feature of this integration? First, APS system can extract some input data from different ERP modules. Here we have uh, we have 6 modules in ERP that can fit information to ERP system and perform automatic calculation on the basis of scientific optimization methodology, and also to generate report. And this report can be distributed across the supply chain, not only across the internal organization. And therefore, APS modules are mainly dedicated to deterministic planning. However, there are uncertainties on both the inbound, for instance, suppliers' unreliability, like machine breakdowns, and also at the outbound, for instance, like unknown customer demand side. In order to hedge against this uncertainty, buffers have to be installed, either in the form of safety stock or safety time. So APS practically a practical application is not an easy task. First, there is a discrepancy. There is a discrepancy between the expectation of companies and the capabilities of the software. Second, optimization models can often not be solved within reasonable time limits because of the complexity of the supply chain networks, and therefore it can be late to receive the optimal solution from APS when the planning is really necessary for the supply chain to be uh, to be undertaken. And third, uh, the willingness to share information, for instance, cost or capacities, it is related to trust issues. And therefore, in order to apply ABS successfully, one thing that should be have on hand is that there is some kind of coordination, cooperation, and collaboration across the supply chain. Because, for instance, it is quite difficult to share the demand information from retailer to wholesaler because of competition, and therefore it is there is a need to have some kind of like uh, trust across the supply chain and also cooperations to make APS works properly. And also often problems in using generic model formulation, which are often not sufficiently tailored to the needs of the specific application environment. Meaning that in order to apply APS, there should be one guy who has specification in mathematical programming or industrial engineering to be able to model and also to solve the model by using APS. It is not simple task because that guy should be proficient in modeling and simulation. And APS maybe to be more successful for intra-company supply chains with centralized uh, logistic control. Because in centralized logistic control, trust is not an issue because the decision taken centrally and the lower hierarchy must follow whatever the upper hierarchy will decide. Again, the management consists of 5 main functions: to monitor the processes, to notify about an impermissible parameter deviations that happen in shop floor, to simulate possible adjustment action. Maybe if you are familiar with a digital twin, that is some kind of online simulation to uh, to see or to observe possible correction if a particular action taken in shop floor, and select a control action to eliminate the deviations by using some kind of control mechanism in shop floor control, and to measure on the basis of the performance indicator, so how much uh, the accuracy of a particular process to meet the expected uh, performance that is set by planning system, that is ERP or supply chain or APS. Okay, now we are focusing on RFID, one technology that is used for supply chain execution management. So RFID is an automatic identification method relying on storing and remotely retrieving data using devices called RFID tags or transponders. So there are three characteristics of RFID, that is passive, can be active or semi-passive. That is three options that can be chosen when we intend to implement RFID technology. Okay, the common target of RFID is to reduce costs created by manual operating, to accelerate also data receipts and transmission, and to increase the preciseness and quality of data. So RFID technology allows tracking products throughout the supply chain from supplier delivery to warehouses and point of sales. This contributes to the reduction of uncertainty of fluctuation in processes, improvement of the readability of the quantity and quality of items produced, also to improve the safety, in particular reduction of counterfeiting and reduction of waste and theft. And also there is some records about RFID that RFID can reduce the error where picking a product in inventory is at 5%. Theft at retailer reduced by 11 to 18%. Shrinkage at retailers decreases and becomes 0.78% instead of 1.69%. Theft on shelves decreased by 9 to 14%, while the reduction ranges between 40 to 59% in stores. So stock availability increases by 5 to 10% because of the integration, and therefore uh, a retailer can send automatically his or her inventory level directly to wholesaler, and the wholesaler will not missing any information about when to deliver. In practice, uh, RFID mostly implemented in international supply chains or supply chain that operate globally. For trading, this movement of goods, also in warehousing, also in food traceability. There are some plus and minus of using RFID. For instance, the plus points are that up-to-date data. It's contact-free because RFID can be plugged or can be placed into a delivered product, and therefore for quality control or for instance, in a warehouse, and there is no need to touch the product, but using the robots or maybe using like employee in one particular warehouse only need to have some kind like a tag to identify uh, products in the shelf of the warehouse. And so did bulk reading, and also it give a protection and security that we have already discussed before. However, RFID also employ some cost, but nowadays the cost is decreasing significantly. So RFID is more acceptable by industry. Also some technical issue and privacy issues. Okay, now the future of IT for SCM. In the coming years, new ITs will change the landscape of marginal concepts and design support system for SCM. Associating and even embedding IT and intelligence into supply chain planning and organizational structure has been discussed for over 10 years now. Therefore, nowadays, a smart supply chain is more popular than smart manufacturing. However, questions remain about the benefits and obstacles in allowing orders, deliveries, and products to be able to plan and control their own progress through the supply chain. With new IT, data management becomes a competitive advantage for companies. Trends in IT development for supply chain management include business intelligence and big data analytics, cloud computing and software as a service, e-business, net marketplace, e-hubs, and virtual enterprises, and also iOS, Internet of Services or Internet of Things, and Industry 4.0. And therefore, IT now is nowadays or recently not only implemented for transaction or exchanging data, but also for operating hardware. For example, like autonomous robots that can be collaboratively operated in from different places across the globe. And therefore, the future IT is not anymore related to data integration, but also hardware integration, and what is we called recently as a Internet of Things that integrate between hardware and software.